the universe. It's a near certainty that it will end, but astrophysicists remain divided on how. Some theories suggest that the collapse of one universe may trigger the birth of another. A godless universe is exploring the three main theories: the Big Rip, the Big Freeze, and the Big Crunch. A fate in which the cosmos doesn't simply fade away in a cold freeze or tear itself apart atom by atom. In the Big Crunch, the universe collapses back upon itself, compressing everything in existence into an inescapable singularity once again. If the Big Crunch is our universe's destiny, it follows an unsettling timeline. The cosmos will continue to expand for billions of years. Galaxies will drift farther apart as space continues to stretch. Billions of years before the Big Crunch, the universe stops expanding. At this stage, the universe is hundreds of billions of light years across. The reverse has begun, and the rate of collapse accelerates with time. The relentless pull of gravity reverses the expansion, and everything will begin to fall inward. In the first phase, galaxies begin to move back towards each other. Slowly at first, but then with increasing speed, as gravity takes control of all matter. The cosmic web that holds the large-scale structure of the universe together will begin to tighten, pulling galaxy clusters toward one another. A few billion years before the end, the collapse intensifies as galaxies begin to collide and merge on an unprecedented scale. The universe has shrunk to only a few billion light-years across, much smaller than today, but still vast. The once dark and endless expanse of the universe becomes increasingly crowded as the night sky lights up from the collision of merging galaxies. There will be a brief period of intense star formation as clouds of gas and dust are thrust together, creating the perfect environment for gas to coalesce into stars. But this burst of star formation is only the beginning of the end. As the universe continues to contract, temperatures rise. The cosmic microwave background radiation, the faint glow left over from the Big Bang, will become hotter as space itself collapses upon itself. A few million years before the final crunch, the chaos will escalate. The universe may now only be a few hundred million light-years across. Galaxies, once vast and majestic, will be shredded by gravitational tidal forces, their stars scattered and thrown into a chaotic random motion. The intense heat of compression will reignite dead stars, but this second life will be brief. The increased density will lead to an era of unimaginable destruction, where entire solar systems are obliterated as gravity intensifies and continues to crush the universe. As the contraction accelerates, black holes will dominate the cosmos. A few thousand years before the end, stars and planets are obliterated as the universe compresses further. The entire cosmos has shrunk to roughly the size of our Milky Way galaxy. Black holes become massive in a short amount of time, feeding on entire clusters of stars. A few weeks before the end, black holes dominate what is left of the universe as they merge into a single supermassive entity. The universe is now only a few thousand light-years across and collapsing quickly. In the remaining few hours before the final singularity, all black holes merge into a single supermassive behemoth. The universe is now only a few times larger than our solar system, as millions of black holes form a single monstrous void at the center of the collapsing universe. Even space itself begins to curve toward this final, inescapable point. Minutes before the end, the remaining matter in the universe compresses into a dense, fiery inferno of mass, roughly the size of Earth. The temperature would be unimaginable, heading towards the theoretical maximum of 10 to the power of 32 Kelvin, or 100 million trillion degrees. With only a minute left, every atom is crushed and destroyed as the temperature continues to march towards the theoretical maximum, not seen since the first moments after the Big Bang. In the final seconds, all remaining matter is forcibly crushed together into a single, infinitely dense point. The laws of physics, which have governed the cosmos for billions of years, cease to exist. Time ends and no longer has a place in this extreme condition. In other words, it does not exist. And then, just as the universe was when it was born in an instant of unimaginable energy, the universe collapses into nothingness, a point infinitely dense and infinitely small. However violent it may be, the Big Crunch presents an intriguing possibility. Could it be the beginning of something new? Some theories suggest that the collapse of one universe may trigger the birth of another. If the singularity that ends everything reaches conditions similar to those of the Big Bang, it might not just be the end of time, but the rebirth of a new cosmos. This concept is known as the Big Bounce. It suggests that the universe is eternal, cycling through endless phases of expansion and collapse, destruction and renewal. If each universe is born from the death of the previous one, that would suggest that our reality has existed before in an infinite birth, destruction and renewal cycle. Will the stars be reborn in the distant future, in another version of our universe? No one knows for sure, as the Big Crunch is not a certainty. Current evidence suggests that dark energy is pushing the universe toward an eternal expansion, leading to a big freeze or even a big rip, rather than a collapse. But dark energy remains one of the greatest mysteries in physics. If it changes over time, if it weakens or behaves differently under extreme conditions, the Big Crunch could very well be our fate. Unlike the Big Rip, which shreds reality apart at its very foundations, or the Big Freeze, which leaves a cold, empty void where nothing ever happens again, the Big Crunch offers a different kind of ending. One that is violent, but also full of new and fresh potential. A universe that destroys itself may also be one that creates itself once again. But if the Big Crunch is our destiny, then one day everything we know will fall inward, collapsing into a single, infinite moment of destruction. And if the universe truly is cyclical, something new will rise. A new dawn, a new opportunity for life to prove its worth in a new cosmos. This is the Big Crunch. But that's not the only theory of how the universe will end. What if everything in the universe, every brilliant star, every black hole, galaxy and subatomic particle, from neutrons, protons and electrons to quarks and neutrinos, were slowly edging towards a lifeless oblivion? An oblivion, not in the form of a colossal end like the Big Rip or violent rebirth like the Big Crunch, but a slow crawl to becoming a cold, lifeless, black abyss. This scenario is called the Big Freeze, a slow, silent fade, a quiet end to everything in the entire cosmos. It's a universe that simply runs out of energy, winding down over unimaginable eons until nothing remains but cold, dark, empty space. Ever since the Big Bang, the very fabric of space-time has been expanding at a rate that is faster than the speed of light, carrying galaxies away from one another at an alarming rate. The arrow of time is forever moving forward, relentless and unfazed, and if the Big Freeze is the fate of our universe, that arrow is not leading toward an explosion, but toward an eternity of silence. In this scenario, everything, galaxies, stars, planets, and even the very atoms that make up reality, are slowly being stretched apart, cooling down, and losing all ability to sustain energy. A future where time itself is stripped of meaning, where the cosmos is nothing more than an empty void, expanding forever into absolute oblivion. At first, scientists believed the expansion of the universe may slow down over time, even reverse, leading to a catastrophic collapse known as the Big Crunch. But then, in the late 1990s, astronomers studying distant supernovae made a shocking discovery. Not only is the universe expanding, but that the expansion is accelerating, forcing galaxies apart, preventing even gravity from pulling them back together. This unknown force is known as dark energy and makes up roughly 68% of the total energy in the universe. It remains one of the great mysteries in physics, driving space apart at an ever-increasing rate. If dark energy continues to drive this expansion, galaxies that are visible to us today will drift farther and farther apart. Their light stretched until they become too distant to ever be seen again. Eventually, the observable universe will shrink to the point where nothing outside of our local group of galaxies is visible to us. Future civilizations will look up at the night sky and see nothing beyond the stars of their own isolated galaxy. The once vast cosmos will appear empty, as if no other galaxies had ever existed. But as space expands, it also cools. This is a fundamental law of thermodynamics. As energy spreads out, it becomes more diffuse and temperatures drop. Stars that burn brightly today will one day exhaust their fuel, becoming white dwarfs, neutron stars, or even black holes. The once great furnaces that lit the universe for countless billions of years, forging elements and sustaining planets, will one by one flicker and eventually die. In 1 trillion years, the last of the near-immortal red dwarf stars will finally fade, along with white dwarfs that no longer have nuclear reactions to sustain them, eventually becoming black dwarfs, dead, lifeless, and void of any energy. The entire cosmos slowly cools with dead, cold, lightless remnants of stars, floating endlessly through space, leaving behind a universe without any light and without any heat. The cosmos, once ablaze with an endless expanse of stellar brilliance, will descend into an era known as the Degenerate Age, where the only thing that remains are the cold, lifeless husks of trillions upon trillions of dead stars. But what about black holes? Will they survive the brutal emptiness of the Big Freeze? Despite their awesome presence, nothing, not even black holes, will survive. Through a process called Hawking radiation, they will slowly evaporate over an unimaginable time span, trillions upon trillions of years, leaking energy, particle by particle, into the void until they too vanish. For a typical black hole, this process will take 10 to the power of 100 years, or what is also called a googol, a number so large that it defies human comprehension. But eventually, even the most massive black holes will dissipate into nothingness, releasing their last whisper of energy into an already frozen universe. And when the last black hole disappears, the universe will be left with nothing but the faint, lingering glow of background radiation. Heat spread so thin that space itself will hover just above absolute zero, the coldest temperature possible. An endless black void forever at rest at minus 273 degrees Celsius or minus 459 degrees Fahrenheit. All meaningful interactions cease. There will be no more galaxies, no more planets or stars, and no more life. Even atoms themselves will decay over vast stretches of time, breaking down into fundamental particles, drifting endlessly through the void. The universe will enter the dark era, a time when entropy has reached its maximum and no energy remains anywhere in the entire universe. It will be a cosmos of silence, where time continues but absolutely nothing happens, an eternal graveyard of a once vibrant, awe-inspiring existence. The most unsettling thing about the Big Freeze is not just that everything dies, but that nothing ever happens again in the entire universe. In the Big Rip, space itself is torn apart in a violent ending, a runaway expansion that ceases to slow down. In the Big Crunch, there is at least the possibility of a new beginning, a rebirth from utter destruction. But in the Big Freeze, there is no final moment of time, no reset button, no rebirth. Time continues, but in a universe where there is no energy left to do anything, a universe where existence has become nothing more than an eternal, endless void. Could anything escape the lifeless fate of the Big Freeze? Some physicists speculate that advanced civilizations may find ways to harness the last remaining energy of the universe, finding ways to stretch their survival almost indefinitely. Others theorize that if the fundamental laws of physics allow, new Big Bangs could be spawned, seeding fresh universes within the remains of old ones. But these are purely speculative ideas, far from anything science can accurately predict. What we do know is that if the Big Freeze is the true fate of our universe, then everything we know is temporary. The stars, the galaxies, the very building blocks of matter, all of it is dying in a slow, unstoppable drift toward nothingness. This is one of the possible final fates of our cosmos, the Big Freeze. But most astrophysicists, astronomers, and cosmologists agree the universe will come to an end. Everything, every star, every planet, every atom is racing toward its inevitable destruction. Time is dragging the cosmos toward a final catastrophic fate, and there is one possibility that stands out as the most violent: the Big Rip. A future where the very fabric of space is torn apart, where galaxies unravel, where stars and planets are torn apart, where even atoms themselves are shredded into nothingness. This is not just the death of the universe, this is total annihilation. The Big Rip is perhaps the most unsettling yet fascinating of the three theories regarding the ultimate fate of the universe. Unlike the slow, cold demise of the Big Freeze or the violent rebirth of the Big Crunch, the Big Rip suggests something far more dramatic, a final, accelerating expansion that tears the universe apart, molecule by molecule, until even the concept of space ceases to exist. To understand the Big Rip, we need to start with what we already know about the universe's expansion. Ever since renowned astronomer Edwin Hubble made his groundbreaking observations in the 1920s, we've known that the universe is not sitting idle. It's growing, stretching, expanding outward in all directions. At first, scientists assumed gravity would eventually slow this expansion down. Maybe in time it would even reverse, leading to a big crunch, where everything collapses back into a singularity. But then something was discovered that was unexpected. In the late 1990s, observations of distant supernova revealed that not only is the universe expanding, but that expansion was actually speeding up. Something mysterious and powerful is pushing galaxies apart at an ever-increasing speed. This force, dubbed dark energy, makes up roughly 68% of the universe's total energy content, yet we still have no idea what it actually is. The more we study dark energy, the stranger it becomes. Unlike gravity, which weakens with distance, dark energy seems to remain constant. But if dark energy grows stronger over time, its repulsive force would eventually overcome all other forces in the universe. This wouldn't just cause galaxies to drift apart, it would accelerate expansion to such an extreme that, one by one, galaxies, stars, planets, and even atoms themselves would be torn apart, unraveling reality at its most fundamental level. So how does this cosmic nightmare play out? The answer lies in how dark energy behaves over time. If dark energy remains at a steady level, the universe will continue expanding, but in a manageable way. But if dark energy's strength increases, as some models suggest, then its repulsive force will eventually overwhelm all other forces in the universe. The Big Rip follows a terrifying timeline. A few billion years before the end, the expansion of the universe has accelerated to such an extreme that distant galaxies become unobservable. Their light is red-shifted beyond detection, meaning that if any intelligent beings are still alive, they will see nothing but the stars of their own local galaxy. The vast cosmic web that once connected galaxies begins to unravel. A few million years before the end, gravity, which has held galaxies together for billions of years, starts to fail. One by one, galaxy clusters break apart and the individual galaxies drift away from each other into the endless void. Eventually, every galaxy, including the Milky Way, is torn apart, scattering stars and planets across the cosmos. Days before the end, planets and stars themselves succumb. The forces that bind solar systems break down. Planets spiral away from their stars, with the stars themselves beginning to disintegrate as the nuclear bonds within them weaken. Minutes before the end, the destructive force of dark energy overtakes the atomic scale. The electromagnetic forces that hold molecules and atoms together are overwhelmed. Atoms are ripped apart into subatomic particles, and in the final moments, even those particles disintegrate. The final instant arrives, and space-time itself is torn apart. There is no more distance, no more time, just a final, absolute dissolution. The fabric of the universe ceases to exist. And then, there is nothing. It's one thing to imagine the death of our sun, or even the end of our galaxy. But the Big Rip suggests an ending that is far more absolute, an unraveling of existence itself. Unlike the Big Freeze, which suggests a slow fading into darkness, or the Big Crunch, which could potentially lead to a new universe being born, the Big Rip offers no such continuity. It is a total, irreversible annihilation. What happens to space and time if the very framework that defines them is destroyed? Could there be something beyond the Big Rip, some other form of reality? Or does existence itself cease in every conceivable sense? From a human perspective, these questions feel deeply unsettling. They force us to confront the idea that the universe, which seems so permanent and vast, is not eternal. More than that, it suggests that even the laws of physics, the very things that govern reality, are not immutable. They can change, they can break, and ultimately, they might even self-destruct. For now, the good news is that if the Big Rip scenario is correct, it's billions of years away. Current estimates suggest that if dark energy is growing stronger, it's going to take at least 100 billion years before things get truly apocalyptic. That's far beyond the lifespan of Earth, the Sun, and likely humanity itself. But the unsettling reality is that we still don't fully understand dark energy. It could behave in a way that is unpredictable. Some physicists speculate that changes in dark energy's properties could accelerate the timeline. Others suggest that the Big Rip might never happen at all, and perhaps dark energy will stabilize. Perhaps something else entirely will take over the fate of the cosmos, something that we do not see as of yet. Whether or not the Big Rip is the fate of our universe, the idea forces us to think about the impermanence of everything. The universe, for all its grandeur, is not eternal. Like everything else, it has a beginning and, quite possibly, an end. But does an ending confer a sense of meaninglessness? Or does the very fact that we exist now, in this brief window of cosmic time, make our existence more profound? The Big Rip, if it happens, is billions of years away. We are fortunate to live in a time when galaxies still shine, when planets still orbit stars, when life, at least in one small corner of the cosmos, has the chance to think about its own place in the grand story of the universe. Perhaps that's what truly matters. Not how the universe ends, but how we use the time we have before it does. As we look up at the stars, as we ponder the mysteries of the cosmos, we should remember, the universe may be temporary, but our curiosity, our wonder, our desire to understand, it is these things that give meaning to existence, no matter how it all ends. We hope you enjoyed spending your time with us exploring the Big Rip ending of the universe, and invite you back for our next episode,